Hello to all physics enthusiasts and fans of physical experiments. This is Andrei Shchetnikov with you. And since we've started various discussions about jet engines and jet propulsion, I want to mention a well-known children's toy, the steam-powered boat, also known as the Pop-Pop boat. It consists of two parts, the hull and a copper tube, which is coiled here several times into a ring. This will be the steam boiler. And from the boiler, two tubes are bent downward, from which the jet streams will be emitted. But before launching, the boat needs to be filled with water. These two tubes are used so that water can be supplied through one of them, while air exits through the other tube. Now I place the little boat on the water. I take two candles. These will be my heat source, and I light them. I place the candles under the boiler. Now we need to wait a little while for the boiler to heat up. And now the jet engine has started, and the little boat has begun to move. But we have so little space that it will have to go in circles. In the meantime, let's think about what questions might be asked here. And, of course, the first question. It's about how this device works. How is it that jets are emitted from it, and the jets keep on being emitted? We see that the little boat is gently vibrating. This means that the jets are emitted in pulses. Puff, 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 puff. And we also need to ask how such jet propulsion is even possible with the intake and expulsion of water. We have asked this question more than once, but it makes sense to repeat it here as well. And let's first discuss how the jet propulsion of the boat occurs with the periodic expulsion and intake of water through the nozzles. Here we have two languages, acum, the language of the laws of conservation of momentum and the language of acting forces. And we will discuss this in both languages. First, let's consider the expulsion phase. So from the boat, as hydrodynamicists say, a submerged jet flies through the water, carrying momentum with it, and accordingly, the boat acquires the same momentum directed in the opposite direction during this expulsion. And now, in terms of forces, the same thing. When we expel the water, the acceleration occurs somewhere here. At the exit, from the boiler, and then the water flies by inertia. It flies by inertia, and the tube redirects it. And accordingly, from the side of the tube, a redirecting force acts on the water in that direction, the horizontal projection, while from the side of the water on the tube, a horizontal force can be depicted in the opposite direction. This force is what moves the boat during the expulsion phase. Now, the suction phase. Here we have a different situation. Here, stationary water from outside is drawn inside. This water, of course, accelerates through the tube, but then it hits this wall and rises upwards. It turns out that the momentum of the water here was zero. It gained some momentum and then became zero again. I mean, the horizontal projection. Well, consequently, the water did not gain any momentum in the horizontal direction. And the boat didn't gain any either. And now in terms of forces, when we suck in the water, the acceleration of the water occurs right here, which means that the pressure in the tube is now less than the hydrostatic pressure at this level. So it turns out that the hydrostatic pressure is pushing from the outside, while the pressure inside is lower. And I should draw a force here that acts in that direction on the boat, towards the stern. But after all, the water moves through the tube and turns here. Therefore, it presses on the tube from the inside, and we can refer to the horizontal projection of this force. These forces balance each other out, and as a result, the boat does not move due to any forces during the suction phase. And all this is similar to how octopuses move using jet propulsion, by sucking water into their sac through a nozzle and then expelling it backward. As a result, they move forward and do not remain in place. Now, the second question, how does the steam boiler itself work? Why does it move the water back and forth? Well, we have two areas. The hot area is this heated tube coiled into a ring, and the cold area with water. Now watch what happens next. The steam expands, pushes the water out of the tube, penetrates into the area where there was just relatively cold water, cools down there, condenses, contracts, and the water moves back. And thus, it happens pulse after pulse. But here, an attentive viewer should ask, why does this thing pulse at all? Why doesn't it happen that the steam pushes the water a little, it lowers in level, and then no further movement occurs? And that's the first important question. And the second important question is, at what frequency does all this occur? What determines the frequency at which the water moves back and forth in the tube? Well, I would like to leave these questions open for discussion, and you can share your thoughts on this matter in the comments section of this video on YouTube.